page 249 in your textbooks, and you had just 3 systems of equations to solve. One of them, solving by graphing, that was number 2. We haven't done that in a little while, so let's go and review graphing systems of equations. There are really 3 ways we graph equations, remember. We could do the whole XY table thing, but that was slow, we didn't like that. We had 2 other ways that really worked well. One was the intercept method, the other was the slope-intercept form. And I'm curious, Maddie, on your first equation, the x minus 2y equals negative 1, what did you do to get your graph? You went slope-intercept form, right? So how did you rewrite the first equation? All right, so perhaps set the x over as a negative and then divided everything by a negative 2. And that would get you y equals, you said, a half x, positive a half? And that is correct. So the 1/2 is a little annoying, but not awful, right? I mean, 1/2 isn't too hard to plot with relative accuracy, at least. And then rise 1, run forward 2. So rise 1, we're up to 1.5 now, forward 2. And when you connected those dots, should have gotten a line that looks something like, if this thing will stay against the chalkboard, something like this. How many had this for your first line? Had this for your first line, okay? Question?
My brain was in substitution mode and I did the whole thing wrong.
Oh, you didn't graph it despite me
No, I did graph, but I mixed it up.
Oh,
I
okay.
don't know what I was thinking.
She has a weird brain.
Okay, well, now that you've seen it, let me have you take the lower equation and either use intercepts or slope-intercept form for this one.
Slope-intercept form.
All right.
So, y, or 4y equals negative x negative 7, and then divide 4. So y equals negative 1/4 x, negative 7/4.
Now, when we see negative 7/4, practically speaking, for the sake of the graph, that's
1 and 1/4. Or
Plus 2/4.
Shh, ignore him. 4 goes into 7 with 3 left over. So 1 3/4. So rather negative 1 3/4.
I thought I said that.
You said 1 1/4. I think you were thinking the 1 3/4 because you said it with a great deal of confidence. Negative 1 3/4. So this one's going to be a little harder to graph, but as long as we put our point kind of close to that negative 2, and then from there, Abby, we're going to rise
1,
and go backward
4.
4. So rising 1 puts us at negative 3/4. Backward 4 puts us right about here. And we'll connect those dots as well. And we get something like this. How many had something like this for your second equation? All right. And then where they intersect, it appears to be almost exactly at negative 3, negative 1. So that's what appears to be the solution. But frankly, as weird of fractions as I had in there, it wouldn't be a bad idea to try to check. How would I check something like this, Brandon? I could plug those numbers in. If I plug in a negative 3 here and a negative 1 here, would that give me a negative 1, class? Yeah, okay, so that makes me think probably we're on the right track. And if I did the negative 3 and the negative 1 here, does that give me the negative 7? All right, so yeah, it really does come out to negative 3, negative 1. And how many have that on your graph? You had your graph work out like that?
I had that.
Well, yeah, you just said you solved by substitution and got that, though. How many solved by graphing and got the graphs to intersect there? Okay, just a few of you. If nothing else, we figured out why we don't like this way. All right, so good refresher. You know, sometimes need to be reminded why we hate things. Like as a Cardinal fan, why do I hate the Cubs so bad? I have to be reminded sometimes. And anyway, though, it may or may not happen this season. Baseball's locked out. No baseball games going to be played. Players want more money. Owners don't want to give it to them. Economics. Who's in economics? Nobody's in economics. Okay. Anyway, talking about labor and all of that. All right, let's take a look at number 4 and number 6. Number 4 and 6 you can solve either by substitution or elimination. It was your call. Number 4, what did you get for your answer, Kendall?
6, 8.
Uh-oh. 8, 6. Careful to put the x and the y in the correct order there. And for redemption, Kendall, number 6.
Negative 3, 1.
Negative 3, 1 is correct. How many got both of those right, 4 and 6, regardless of how you solved them? Does anyone need to see either of those work, 4 or 6? I didn't get that. Questions? All right, let's take a look at some word problems then. And we've been working on several different kinds of word problems here over the last several days. This first one is just I get the camera where I want it. This first one's really straightforward, really basic. At your seats, take just about probably a minute and a half to solve. Shouldn't take much more than that. First equation, Brandon?
3x equals 4 plus 2y.
Good, or 2y plus 4 is generally how I'd write it, but it's not wrong. Addition's commutative. Abby's second equation?
X plus y plus 13.
How many had this for your system? Again, 2y plus 4 would be the same thing, but you had the system. All right, and when you solve for the two numbers, what did you end up with, Michael?
What?
What were your two numbers?
Oh, 6 and 7.
Good, so, wait, 6 and 7.
Yeah. X is 6y. You asked me for my two numbers.
Okay, sorry, my brain was trying to check it on the spot and I wasn't coming up with that. Yes, if that's the 7, yeah, so 6, 7 in that order. Does check out, all right? I got to check here. I was trying to check it there off the top of my head because I didn't know what the answer was. I hadn't worked it yet. But that is correct. How many also got 6 for x, y for 7? All right, questions on this. How many solve substitution? Solve substitution. How many move the 2y over and multiply maybe a 2 through the bottom, solve by the addition method? Either way works. There any questions on basic systems? All right, let's take a look at another type we've been working on more recently. We've been working on these 2-digit number problems. Take a few minutes now to work on this one. All right, so remembering that the tens digit is t, the units digit is u, and the number is 10t plus u. Audrey, how would we write our first equation?
U equals t plus 6.
That's correct. U equals t plus 6 is correct. And how about your second equation there, Genesis?
10t plus 6
And that's also correct. How many have this system then? This system. All right, I might go ahead and pull the u over to get a 2u or a negative 2u, and then do the substitution. What did you end up with for your number, Kendall?
28.
28, and let's see, that satisfies the first requirement. Is that 4 more than 3 times the units digit? Yes, it checks out. How many had 28 as the number? Okay, only a few of you. Let's take a look at this real quick. If I subtract this to get 10t equals 2u plus 4, by the way, I could knock a 2 out of this if I wanted to, right? Yeah, why not? 5t equals u plus 2. I like numbers the smaller they get. Maybe plug in that t plus 6 right here. So 5t equals t plus 6 plus 2, or t plus 8. 4t equals 8. There's the t equals 2. And there's the 28. Again, not that you had to solve substitution. Questions on this one? Questions at all? 2-digit number problems. All right. And then it's been a couple days since we've worked on one of these. An investment problem. Remember, I equals PRT, or rather PRT equals I at your seats. Take a few minutes to work this problem. For our system, most of you, right, remember the amounts invested, we don't know either one of them, call them X and Y. The rates become decimals, 0.02 and 0.01. So since time is a year, we kind of just ignore the 1. And so 0.02x is the interest earned on this account, 0.01y the interest earned here. Most students realize your equation is going to be X and Y get added together to get something. 0.02x and 0.01y get added together to get something. The problem some students have is which one goes where. Well, this column class is labeled with P. P stands for principal. That refers to the amount of money that is invested or borrowed. In this case, invested. How much money was invested, class? 5,000. So the 5,000 has to be the X plus Y. This column has an I. I stands for interest. That's the money you make on your investment or the money someone else makes off of you if you borrow, right? This is money made on investment. Well, how much was made on investment? What was the interest? 85. So if we remember, the interest plus interest has to equal interest, and principal plus principal has to equal principal, we should be good. Also, what am I going to have to do in the decimally equation, class? We have to move it, boink, 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 right? So if I have a really big number here and I boink, boink, that's going to make it way bigger, and there's going to be a little bit of disparity. So just kind of thinking through that way as well, the boink, boink that gives me the 2x and the boink, boink that gives me a 1y or just y gives me a number that's more in the same ballpark now. Does that make sense? So that might be another way to think it through. I'm just going to go through and change the signs across the top, cancel the y's. 2x minus x is just x equals, class, $3,500. So that's the amount that Sam invested at 2%, $3,500 at 2%, and it wanted each account. 5,000 total, right? So 3,500 at 2%. How much at 1%? $1,500 at the 1%, and there are my answers. And I'm going to have this for this word problem. Questions on this word problem? Any questions on interest? Going once. Going twice. All right. Go ahead and, if you would, on your paper, go and copy down the system of equations that you see here on the chalkboard. We're going to spend the rest of today figuring out systems of three unknowns, systems of three equations. as many unknowns as you have, as many variables as you have in the equation that you're solving for, that's how many equations you're going to need. So 2 unknowns require 2 equations. 3 unknowns now would require 3 equations. Could we do a system of 5 unknowns? We won't in this class, but we could. And how many equations would we have for 5 unknowns class? 5 equations. The neat thing is, and the reason we stop at 3 is the process we're about to use here, you would use no matter how many unknowns, no matter how many equations. The key is to whittle down unknowns until eventually you get to a point where there's only 2. So we're just going to show it with 3. The idea here, though, Abby, we don't like 3 unknowns. We got very comfortable with 2 unknowns. So we want to get rid of one of these 3 letters completely. It's like that sibling you just bothers you all the time. All right, so which of these is the sibling that bothers you most, X, Y, or Z?
Y.
I'm about to say, you can't say Michael. You have to say a letter. All right, so Y. So Y is the letter that Abby has chosen to get rid of. Now, Abby, we're going to have to get rid of Y twice because it doesn't go away easy. Well, anyway. All right, so what we're going to do, Abby, we've got 3 equations. We're going to pick any 2 that you think we can knock the Y out with.
The first 2.
The first 2, absolutely. And if you wanted to, yesterday, admittedly, I went a little faster than maybe I should have for first showing it. So many of you kept up just fine, but maybe should have slowed it down a little and showed more steps off to the side. So if you wanted to, you could rewrite those 2 equations off to the side. Now, I try to do more in my head because I'm lazy, but no, not a problem taking those 2 equations, writing them off to the side. And to knock the Y out of these 2, Abby, all I have to do with these 2 equations is combine them. Just add them. And what do I get?
9x plus 2z equals negative 25.
There we go. And again, if you're unsure of yourself on a quiz or test or even homework, certainly pull out the calculator. And what I'm going to do is I'm going to go ahead and box this equation because now we are pleased with this equation. You know why? There's no y in it. We didn't like y. We got rid of y. But we have to do it not once, but twice. We have to find another pair of equations, but it can't be the first 2. It's either got to be the first and the third, or the second and third. But we're going to knock out y again. Abby, which 2 equations do we want to use to try to knock out y a second time?
The first and third.
I like the first and third because at least the signs are different. So let's go ahead and pull our first equation, 2x minus 3y minus 3z equals 6. And our third equation, the negative x, positive y, positive 2z equals 0. What do I have to do to get the y's to cancel a second time?
Multiply the bottom by 3.
Let's multiply the bottom by a 3 to get
Negative 3x plus 3y plus 6z equals 0.
Yeah, and still equals 0. And now, when I add them together, once again, y's cancel out. What do I have now?
Negative x plus 3z equals 6.
And here's another equation that I'm happy with. You know why I'm happy with it, class? No why. Just 2 letters in it. The reason we do this is to give us 2 equations that each have the same 2 variables. And so I take this equation, and they form their own new system, free of y. So we can make a new equation. 9x plus 2z equals negative 25, and negative x, positive 3z equals 6. This is a brand new equation. No more y, just x and z. And we solve it like we would any other system of equations. Maddie, we could solve by substitution, or we could pick a letter to get rid of. Substitution. So let's rearrange presumably the bottom equation.
X equals negative 6 positive 3z.
All right, so moving the 3z over as a negative, but then changing those signs to get the positive x, negative 6, positive 3z. And we'll take that quantity and put it here where it says x. So now it's 9 times the negative 6 plus 3z plus 2z equals negative 25. All right, Maddie, take it from here as I slide this out of the way a little bit. All right, were you able to keep up with her? I didn't quite. I was just behind her. Good job, Maddie. Fantastic. Anytime you go faster than the teacher, that's awesome. We're going to take that z equals 1, and remember, that's all behind us. We've moved on. The y is no longer in our memory. We now have two happy equations, and we're solving these two happy equations like happy trees and Bob Ross paintings. We're solving our two happy equations for happy variables that we like x and z. We've gotten z, well, of course, what we would always do in any other system. Once you have one unknown, you get the other one. And just plug it back in here where Matt, you rearrange the negative 6 plus 3z, plug in the 1, class we get x equals negative 3. So, we know x and we know z. Our answer, remember, is not going to be an ordered pair, an abscissa and ordinate, but rather we have an x value, a y value, and a z, an ordered triplet. Well, I know the z value, I know the x value. But although we've tried to purge the y from our memory, y still exists, and we still need to find y. What do I do now that I know x and z to figure out the y? Michael?
You gotta plug it in.
Where?
To one of the original equations.
Right, we can't stay here with our happy equations. We have to go back where things are sad. One of these three original equations. Which one?
The bottom one.
I love the bottom one. You've already got a plain old y here. And we're going to plug in the negative 3 for x, the positive 1 for z, and of course, negative 3 class, 3, and then 2 times 1, 2. So this is really a y plus 5 equals 0. Therefore, what is y class? Negative 5. You knew it had to be a negative. And there we go. Negative 5 is our y value, and we've solved our system. Now, Abby, yesterday, not picking on you, just want to make sure you're understanding, you indicated you just felt lost. Seeing it again a little slower, a little bit more work shown, does this help make more sense? Feel like you got it now?
Yeah.
All right, questions from anyone else? I wasn't meaning to single her out, but she was the one who most vigorously indicated she did not get it yesterday. Anyone else in here say, I'm still a little, I think I got it, but I don't really know. I'm still a little, how many feel like, I think I got this pretty well? All right, anyone kind of still on the fence? Michael, that was like a half shoulder shrug. Yeah? All right. So anyway, turn your books to page 242. And we're going to do number 6 together. We're going to do number 6 together. So copy down page 242, number 6. Page 242, problem number 6. Go and copy it down on your paper. And the first thing we've got to do, Michael, is
take out the y.
Knock out a letter. And I like the y once again. Not because I always knock out the y, but 7, 3, and 2, really? All right, that's like, no. Here, 1, 1, and 3, smaller numbers. I just love small. Huge fan of small. And so, yeah, let's knock out the y. Which two equations do you want to start with?
1 and 2.
1 and 2. Now, I'm going to try to take another shortcut here because I really am that lazy. But if I just take the first two equations and I just add them together in my head, I already see that the y is going to knock out. Do y'all see that as well? So I don't need to rewrite them to see that the y knocks out. I can add them in my head and just knock it out right off the bat. Michael, what do we get?
You get 10x minus z equals 15.
And I like that. Now, I wish we could do that every time. It was going to be that easy, but it's not going to be that easy the second time through. We've got to get rid of y again. You've got to do it twice. We have one happy equation. We need a second happy equation. And in order to get a second happy equation, we need to take two sad equations and knock out a y. Which two equations do we want to use now, Michael?
1 and 3.
Let's take 1 and 3. Now, I am going to take the time to rewrite 1 and 3, but I'm going to change 1 because I already know I'm going to have to do what to equation 1?
Or multiply by 3.
I'm already going to have to multiply a 3 anyway. So let's do that in our heads as we copy it.
21x minus 3y plus 6z equals 63.
Perfect. And then the lower equation I'll copy as is. The negative 2x positive 3y positive 7z equals 40. This is going to allow my y's as planned to cancel, and I get a second happy equation. What is my happy equation? Bob Ross would be proud.
19x plus 13z equals 103.
So, one happy equation, two happy equation. What do I do with my two happy equations? Audrey, you look happy. You like math. What do we do with my two happy equations?
You solve it together.
I solve them together. I make a whole new system devoid of sadness. And so I just make a whole new system out of these things. Except as I'm writing it, despite them being happy equations, I feel a little sad. I gotta solve this thing, and those numbers look weird. So, Audrey?
You multiply by 13.
Let's multiply the top by a 13. What does that make my top equation?
130x minus 13z equals...
Big number.
95.
95. No, it can't be 95.
195.
195. That sounds more like it. Okay. And then the bottom equation, I can actually leave that alone. 19x positive 13z equals the 103. And you ever get the feeling you're doing something wrong? I don't know. Let's keep rolling. I don't know what I've done wrong, but you feel like we haven't done anything? Okay, let's keep rolling. We'll combine these two together to get what here, Audrey?
111.
Who?
111. So,
Well, these signs aren't different, are they? They're both positives, aren't they?
just kidding. Hold on.
She was just kidding. We're holding
149.
149x, okay, and then these have different signs. They cancel. That's really happy.
298.
298. You're right, because when we divide, it does divide evenly. I was getting worried. X equals 2. And so there's one of my three answers. X, Y, Z. I've got X. Still need Y and Z. Of course, we've eliminated Y. So we're on to just X and Z here. Probably the best place to plug the X in, class? Top equation, despite the negative. Here, the 10 times 2 Genesis. And we're going to kick it out as a negative 20 to get negative Z equals negative 5. So therefore, Z just equals 5. 2 down, 1 to go. Where do I get my final answer, Brandon? Go back to one of the original SAT equations. He picked the middle. I think that's a great choice. And we're going to plug in the X, which we said was 2. We're going to plug in the Z, which we said is 5. And let's see, 3 times 2, class? And negative 3 times 5, negative 15. So 6, negative 15, class. Negative 9. So we have a Y minus 9, or negative 9 equals negative 6. Move it over as a positive. Y equals 3. So our answer is going to be X, Y, Z, class. 2, 3, 5. My ordered triplet as my answer. Several of you, I saw you working ahead. That's a good sign. That means you know what you're doing. How many worked ahead and got this answer before I did? All right, any questions on this at all? Your turn to try one on your own now. I'm going to give you a head start, and then I'll be working on the board if you get stuck. By the way, I believe these all come out with nice, easy integers for now. And number 1 does work out with nice, easy integers. Do number 1. They're on page 142, or 242, whatever page we're on, that one. I mean, if you don't get an integer for a value, there's a mistake somewhere. At least on this page. How many chose to get rid of the X on this one? How many went Y? How many Z? All right. I went X, I just felt like 1, 4, 3 is easier than 3, 5s, and 2s, but it doesn't really matter, just looks like most of you went X, so most of you will be able to duplicate what I'm doing. If you got the right answer, move on to number 3. If you have the correct answer, move on to number 3. If you don't, and you did it my way, getting rid of the X, see if you can find your mistake, but if you're like, I didn't do it the same way you did, can you come check it? I will be happy to come check your paper for you. If you need me to check your paper, raise your hand, or if you just have a question you want to ask, you can raise your hand there as well. Did you find it, Kendall? Alright, moving on to number 3 once you've checked. Again, if you need help, don't hesitate to raise your hand and ask. Gavin and Brecken wish it were that easy for them. Anyone still working on number 1? How many finished? How many had the correct answer before I did, or shortly thereafter? Okay, and the rest of you figured it out? You're doing great. Perfect. And you knocked out the, the X as well. We'll leave it up a little longer. those of you who are on or were on number, struggling with my camera here, we're on number 3. How many of you wrote down the second equation and thought, ooh, I can knock a 2 out of everything? And how many also almost immediately after that thought, yeah, but I don't want to. Why don't I want to knock the 2 out? It sets up canceling the y so easily. So yeah, here it's actually a blessing there was the 2 there already. Some of you already done. Tell you what, if you're done with 3, go on to 5. I'm going to be putting 3 up in just a moment. And you're good to go. Excellent. All right. So I'm going to erase 1. Y'all are working on 3 or 5. Tell you what, how many are finished with 3 already? Let me check your answers at least. And then you can either try to find a mistake if you have one, or ooh, no. And I'm not sure where the problem hit. That first one's good with pencil. You see how this was a positive 5x? You change it to negative. This should have been a positive 5z, which should have changed to a negative.
Oh.
Or vice versa. Yeah, so you changed a sign that you shouldn't have. You are good on 3, so you can go on to 5 without problem. You say you were finished with 3? Mm-hmm. And really close. Oh, you just copied it over wrong. You had this, but you just didn't write it correctly here. Yeah, otherwise good. Yep. I'm just right in front of the camera. Sorry about that. Got the back of my head up close.
I canceled that and somehow I have to combine it with that. And I think that's
Yeah, so let's see if we can figure out what happened here. I shouldn't take too long. Hang on just a second. As I work, make sure you're checking your work and see, is that what you did? Okay. I'm just going to add them together in my head. Add those together in my head. Like that?
Mm-hmm.
Did you get a negative 5? And these were already set up perfectly to cancel. To get 12x equals, now it's a positive 41 and a negative 5. Should have gotten a 36. I think you got a 46. And that's where you should have x equals 3. And there's the answer to number 3 for those who are finished, and the work for it. Did you find a mistake, Brandon?
It was that sign change.
It was that sign change, okay?
I got that.
That's right, I already see that. That's right. Number 5, remember, is next. How many done with 3? How many finished 3 already? Do we all get the correct answer? All right, and some of you, it looks like, already done with 5 as well. Tell you what, if you're finished with 5, watch as I do it. Make sure you have roughly this. Tell you what, Michael, you two were both done with 5? What letter did you get rid of?
I got rid of X.
X, both of you. Perfect. Good choice. All right. I'm going to multiply by a 3. right, so that's 3, this is 5. Questions on 3 or 5? Questions on 3 or 5? Ooh. Someone else had the same thing. And it's right here. You had that 5x minus 5z equals negative 5? Oh, yeah, right here. You kept a negative 5z, should have been the positive 5z. Yes, and that's actually, Brandon had the same issue, and he had the same answer you got, actually. So that means everything else was probably correct, other than that one thing. For that sake, let's move off of 3. Any questions on 5? Anyone need me to come check 5? How many got correct answer on 5? Let me see where correct answers are. Okay, questions, you two. Did you find your mistake? You're still looking?
Yeah, I didn't finish it, but I had a 48.
Okay, so you got one happy equation here. That looks good. Other happy equation is also what I had. Now I knocked a 2 out of it, but you didn't have to. Solve by substitution. Just a moment here. Negative y plus 5z equals negative 15. If we double swap, that's a 5z minus 15 equals y, which is essentially what you plugged in. Negative 15 plus 5z. Is it positive 30? Z plus 12z equals negative 36. That does combine into 2z. Negative 30, or the negative 66, it's still a negative 33, that's not it. Okay. Alright, y'all can help me here. I'm struggling with something that one of our students had here. I'm going to erase number 3. So this was the system we're at, and I'm going to see if we can find it because more eyes are better, and then we'll move on. We got just one more problem I want to work. So we have this equation without the 2 taken out, and we have this equation. I think I actually just know it. I know what just happened. So you had negative y plus 5 equals negative 15. When the 15 moves over, it becomes a positive. So, or if you move the 5z over as a negative 5z, you get negative. Oh, you lost the negative on the 15. Right, here's the negative 15, you lost the negative. That's all it was. Okay, never mind, we found a mistake. Okay, page 249. Page 249. I'll take a look at problem number 7 with you in the little bit of time we have left. One of my faults. When I get stuck on a problem, I simply must know where the problem was. And anyway, like, just move on. Sorry, I can't. Any of you like that? It's like, you know you want to move on, but you can't. Worst thing is when you play an instrument and you screw up in an instrument, like you're performing or playing, and you have to move on. But like, I couldn't. I had to fix the note and play the correct note before I could go forward. And that really makes life difficult. I'm miserable on everybody. But anyway, we all have our faults. Some more than others. All right, Brandon? I just put it on Brandon. I like Brandon. All right, Brandon. I'm looking at equation number 1 on number 7. And thoughts on the first equation on number 7, page 249? Knock a 3 out of everything to get what?
X plus 2y plus z equals negative 1.
Anytime you can simplify an equation is probably going to be helpful. Second equation, unfortunately, I'm stuck with. And third equation we're stuck with. But hey, every little bit helps. All right. Thoughts? I got people voting for the x, all right? So let's take top 2, but multiply the top by 4 now to get what from my top equation, Brandon? And of course, we'll keep the negative 4x, positive 5y, negative 7z equals 22. Cancel the x's. What's left for our equation now, Kendall?
13x.
13y?
13y. 5z.
Did you get rid of the x?
Yes.
So you multiply the top by 4?
Yeah.
4z and negative 7z?
Negative 3z.
Negative 3z equals
18.
18. All right, there's one happy equation. All right, and then can't do first and second again. I assume we want to do first and third.
Mm-hmm.
All right, but top by 5 to get Genesis. And let me put a negative through the bottom. So I put a 5 through the first. Let me put a negative through the bottom here, Michael.
Sorry, where are we?
Right here, putting a negative through.
Oh, negative 5x. Yeah. Positive 8y. Negative 16. Positive 11.
All right, to get what resulting happy equation, Michael?
Let's see. 2y.
Ooh.
No, 18y. Minus z. Equals 6.
All right, so we have 2 happy equations. What do I do with my 2 happy equations, class? Whole new system, right? Whole new system with them. And so we've got our 13y minus 3z equals 18. We got the 18y minus z equals 6. And what do we want to do now, Audrey?
You can multiply by
Negative 3 in the bottom? I'd rather do the negative in the top than the 3 in the bottom.
okay. 54y negative 3z equals 18.
And I'm going to keep the negative 13y positive 3z equals negative 18 here. And of course the z's are going to cancel really nicely, leaving me with what? Anyone?
Negative 41y equals 0.
41y or negative 41y equals 0, depending on where you put your negative. So what's y? 0. Well, that actually works to our benefit, doesn't it? Because if y is 0, then negative 3z equals 18, class. Z equals negative 6, and we're well on our way if we take our first equation to plug in the 0 and the negative 6 to get x is equal to 5. So what's our triplet answer going to be here, Abby? 5, 0, negative 6. There's our answer for number 7. Questions on systems of 3 equations. All right, yesterday, some of you felt good, some of you were scared, one of you was abjectly terrified. Do we feel confident now that we've got this? That 3 unknowns, although it takes longer, admittedly, right? So it is harder in a sense, is not mentally that much more challenging? You feel good? Homework for this evening. No response whatsoever. Page 250. Do 7 to 14, the teal. On page 250, I want you to do numbers 7 through 14, the teal problems. Page 250, 7 to 14, the teal. So you're working on this. And then move on to some other things tomorrow. Have a wonderful rest of your day. You are dismissed.